For 8, this is in the diagram to the right. BF is the perpendicular bisector of AC, and angle 1 is congruent to angle 2, and they want us to prove that DB is congruent to BE. So moving backwards from that, I can always prove that two parts are congruent if I prove the triangles that they are a part of are congruent. But I don't seem to have a lot of information about these two triangles. I can tell that this, right, is congruent to itself, and I can tell that this is congruent to that. But that's not anything much about these two triangles. So I'm gonna break this down a little more simply and move forward about what I could prove about the other triangles involved first. So they told me that BF is the perpendicular bisector of AC. So that meant these two are right angles. And by bisecting, it also meant that AF is congruent to FC. And I do know that BF is congruent to itself. So right now, I have enough right off the bat, just from this given, to prove that triangle AFB is congruent to triangle CFB. Okay, so I'm going to start with that because I'm guessing that that's going to be helpful to me, because that's going to give me information about, for example, this angle, which is part of that, right? Okay, so we'll start off with BF is perpendicular bisector of AC. That was given, right? So that means that angle AFB is congruent to angle CFB because both are 90 degrees. It also means that AF is congruent to CF because that's the definition of a bisector, right? And then we know that BF is congruent to BF because a segment is congruent to itself. That's enough to prove that triangle AFB is congruent to triangle CFB by side, angle, side, and scale factor of 1. Now, because of that, we can then use information like we now can say that angle ABF and angle CBF are congruent. So angle ABF is congruent to angle CBF because corresponding parts of congruent triangles are congruent. So that actually, if we're looking back up here, that gives us some information about this right here, right? These two angles. And now it's looking like, notice I have now this information, that's an angle. I have one side, right? So now if I just had like another angle, and what's perfect is now we can bring in this given information about angle 1 and angle 2, right? So it's like we're drawing this in here now, right? So I'm going to start bringing in this extra information. Angle 1 is congruent to angle 2, right? And we know that angle AFB is congruent to angle CFB. So that means that these two have to add up to 90 degrees. And if these two are equal, then what's left over have to be equal. So I just was able to say through that logic. So we know angle 1 is congruent to angle 2. That's given. And that then means that angle DFB is congruent to angle EFB. And that's basically a combination of angle, that's basically angle addition. So, and substitution, because if angle 1 is congruent to angle 2 and angle 1 plus this equals that, and angle 2 plus this equals that, then by subtraction, right? So this is basically angle addition and substitution. So because we're able to say that, right, we now have enough to prove that these two triangles are congruent. So kind of moving over here, triangle DFB is congruent to triangle EFB. Again, this is by angle, and scale factor of 1, right? And then because of that, we now know that DB has to be equal to BE. DB has to be equal to BE. Again, by corresponding parts of congruent triangles are congruent.